This is water efficiency. Talk about the future. This is going to become increasingly important. And this is why. 70% of the Earth's surface is covered by water, but less than 1% of that water is fresh water. Heard that? Only 1% of that 1% is accessible for human use? Uh-oh. And we're not recharging this in a lot of our practices today. So the United Nations Environmental Program projects 2 out of every 3 people will live in water stress condition by 2025. That doesn't sound as far away anymore. And the U.S. government found over 36 states expect to have local, regional, or statewide water shortages by 2013. That is scary. 2010, 3 years away. So we need to think differently. If we have water dropping down from the sky, let's maybe think about how we can reuse that in a smart way, a smart, sensible way. Why not? We just need to implement it. Water savings equals energy savings. Once again, don't think of things in an isolated way. Thinking about how they affect each other is very important. So you reduce water usage in a building, you have energy savings because you're not having to pump, treat, and heat that water. So if you're reducing how much you're using, you're saving a lot of energy. So you're lowering your water and sewage fees if you're reusing rainwater. Many benefits. So I've been throwing around the term potable water, and that is the water that is suitable for drinking. Well, it's stuff that comes in our glass. And that is that finite resource that we were just talking about. So when we talk about reducing water, we're about reducing the potable water we use in our buildings and in our processes and in our daily lives. It's our choice too, how we're interacting with the buildings. But the big picture is really how are our buildings using it, how are our systems using it, because that is such a huge amount of water. And hopefully on a municipal or city level as well, we could be recycling gray water. We'll talk about that. Even on a city level, that's something that Dubai actually did do sustainably. So gray water, what is it? It is defined in a few different ways. It is based on your code, local jurisdiction, what's considered gray water. But basically, it's something that hasn't come into contact with toilet waste or even really just kind of any organic matter. So you typically don't include a kitchen sink or a dishwasher because then you have that organic food as well, and that can be a problem or harder to treat. So we're talking about, in the context of LEED, bathtubs, showers, bathroom sinks, maybe laundry water. Not gray water, kitchen sinks, dishwasher. Check with your code. Gray water reuse, there's a lot of opportunities for this. Treat it, and it doesn't take much treatment before you could reuse it for some irrigation. Or treat a little bit more, and all of a sudden we can use it for flushing our toilets and bring it back into the building. Maybe we're power washing our cars or our houses with it. Maybe janitorial uses, wide range. We'll look at how we can actually use it for our processes as well. So the category in LEED about water efficiency is really about reducing the quantity of water needed for the building, its processes, people, and we're really concentrating on potable water, which is our water bowl that we drink, and reduce the treatment of wastewater. So that's also an expensive thing. Everything we're flushing down the toilet is taking energy and money. So reduce how much waste or treat it on site. So new to LEED 2009 is this prerequisite for water use reduction. So since it's a prerequisite, it's required for every LEED building to achieve. Before, there was not a prerequisite in this category. So this is where we start seeing this changing, adapting to the needs in the industry and for our society. The requirement is 20% less water than the water use baseline. Once again, we have to be comparing against something, or anybody can say they're reducing something. Well, reducing against what? Using a whole lot of it, and they're using a little bit less? what are we actually comparing against? That's what LEED is good for, a universal tool for actually saying we reduce it by 20% based against the Energy Policy Act. Something that we can all identify with, we can look up that standard and see how much water that actually means. So you're using a universal matrix and you're getting checked. So included fixtures are water closets, urinals, lavatories, showers, kitchen sinks, pre-rinse valves. We're not talking about processed water that come from systems. Commercial steam cookers, dishwashers, clothes washers, automatic commercial ice makers. So we're talking about these uses here. WaterSense is something that's affiliated with the EPA, and it's a really good resource to compare a lot of different options if you're looking for low flow fixtures. So calculations, baseline case, water use in a conventional building, landscape or water fixture. So we're looking at irrigation and our water use in the building. So the water reduction percentage is based on total water consumption rather than individual fixtures. That's just how you would do the calculation. Rainwater harvesting, many synergies with rainwater harvesting. So Portland receives between 3 and 4 feet of rainfall annually about. So we could really be using this for quite a few things. Components, typically you've got your roof. It needs to be draining towards the gutters that need to be sloped a certain slope in order to make it drain quick enough to not collect water and let things like mosquitoes or things collect in there. So you have screens and things that protect these systems if you are reusing this water. So there are things to think about. You don't just shoot the gutter into your house. You have to be actually thinking about what we can do to prevent any contaminants or things growing in these areas. So a piping system can convey the water to and from a storage tank or cistern. So then if you're going to pump it back into your house, you need to have a system in place for that. So here's an example of a diagram of a rain barrel or a small cistern. We see this in Northeast Portland quite a bit. You have just this screen input area, so it's getting rid of those big debris. If this is just for irrigation, then you're just going to remove that initial contaminant, and then you have a hose, a flexible hose where you can see the water line, and it can be used then for irrigation purposes. Rain barrel, cistern being the larger application. So here's a little diagram of installing those components possibly. So storage tanks can be inside or outside, below or above ground. This is an example of it being below ground. So if you're in an area that maybe freezes over, it's good to protect it. And also it can be gravity fed, using less energy. So basements are a good storage area. So here the gutter is funneling all down to that cistern in the basement. Just one way to do it. You can put these many different places. You can bury them, you can showcase them in the middle of your building, whatever your preference is. So here's an example from rainwater harvesting systems. They have this integrated approach to some of the rainwater harvesting devices that they supply. So this is an example of everything in one system here and how you pump treat the water. And then it could be reused for a variety of things once you have a system like this that's actually treating the water further than just that initial screen or water diversion. So you can use it for toilets, irrigation, janitorial, building equipment. We'll talk about how it can be used for makeup water, huge waste, all these unseen things we don't think about. But there's potable water being used for really unnecessary things. So we can reduce potable water usage in many ways. And once again, save on bills. We're looking at, economics all the time as well. Cost-benefit analysis. This is if you want a green roof, but you also said, I just want to do every sustainable thing I can do. So I'm going to do a green roof, do rainwater harvesting, I'm going to do everything in my roof I can fit on there. Well, that's great, but you just have to make sure you know what you're doing. And you have to do water balance calculations because the green roofs are going to reduce how much rainwater you can collect. So if you're trying to flush your toilets, you have to know how much you need in order to do that and when you're going to possibly run out. So green roofs are great because we're reducing stormwater runoff, natural evapotranspiration going on, but because of that, you're collecting less rainwater. So conventional roof, 0.8 rainwater collection factor, green roof, 0.65 rainwater collection factor, and this depends on, soil depth as well. So more soil on the roof, like 5 inches, all of a sudden it's 0.38 rainwater collection factor. So that's cutting over half. Water efficient landscaping. 2 to 4 points is in orange, more heavily weighted in LEED 2009. So there aren't a lot of credits in the water section, but they are more heavily weighted now. So it's reducing potable water usage for irrigation by at least 50%. And using strategies we talked about, capture rainwater, you could recycle wastewater once it's treated, and maybe reusing gray water. Plant species is important. Once again, native planting. We should try to do what nature was doing on our site as much as possible, because nature kind of has it figured out. So that's, when we're talking about vegetated space, we're talking about native plantings. Or maybe adaptive plants that weren't there originally, but can be there and not be a big maintenance issue. Don't need irrigation, they're going to survive and thrive. So adapted is not there naturally, but can survive well. Native was already there and can thrive. It was meant to be there from the beginning. So important thing to do right away is to understand your site, understand the ecology of the area, and pick those plants. But not everybody has to be experts on each one of these things. Know that you should talk to a landscape architect or someone that understands that. It's really about knowing what to look for, not falling into some pitfalls where somebody tells you they have a product that solves all the problems and you don't know what questions to ask. That's what we're talking about. You don't have to be an expert in each one of these things. Just being familiar is important. Gray water treatment. So here we have laundry, dishes, showers, funneling into, and dishes probably wouldn't be included in most jurisdictions. Coming down, septic tank, sand filter, could be some overflow, but now it's been treated quite a bit, so it's just being infiltrated